Welcome back to the virtual classroom of ChemBase School of Chemistry. Sound clear? Right, so I'll be continuing from where we stopped in the last lesson. We'll be discussing about the basic structure of the atom, and then we discussed the atomic number, mass number, isotopes, and then the most important discussion was from this point, where we discussed about the suborbitals, the s orbital, the p orbital, and d, and also f orbital, how their shapes and the number of electrons in which each orbital can accommodate. We discussed in detail the Aufbau approach, the Pauli exclusion principle, and at last I explained about the Hund's rule. So based on that, we wrote the electronic configuration of various atoms. I remember we did up to question up to argon, right? Up to argon we wrote the electronic configuration. I said to conclude stuff with the argon, and also the box notation we drew up to the argon. Now to continue with the electronic configuration, I explained that when electrons occupy the order in which the electrons occupy, the first 1s is filled, then the 2s, then comes the 2p, and the 3s, then 3p, and 3d likewise, right? So that's the electrons occupy is referred to as the Aufbau approach, the building up principle, so that the lowest possible energy level is filled first, followed by the highest level. Call this number. And we discussed about the Hund's rule, the box notation. Now, when electrons fill, as I mentioned before, electrons occupy the lower level first and then go to the higher level. There's something called the orbital overlapping, which occurs between the energy levels of 3s and 3p. So the lowest is the 1s, the first energy level, 1s2. Then you have the 2s2, 2p6, and you got 3s2, 3p6, 3d10. Then the fourth one, you have the 4s2, 4p6, you have the 4d10 and 4f14. Now there is something called orbital overlapping, which occurs between the 4s and 3d, where the 4s level is slightly below the 3d level. Right? That means after the 4s2 is filled, then the 3d will be filled. Right? This type of orbital overlapping occurs in beyond 3d as well, but as I mentioned last week, we get only to write the electronic configuration up to krypton. Now the krypton, atomic number 36, stops at 4p6. If you count the number of electrons starting from the very first 1s2 up to 4p6, the atomic number will be 36, right? So up to atomic number 36, you get to write electronic configuration. So up to 36, there is one orbital overlapping, that is between the 4s and the 3d. That means the order in which the electrons occupy is 1s, 2s, 2p, 3s, 3p, not 3d. After 3s is filled, or 3p is filled, what is filled is the 4s. What is filled is the 4s, right? So after 4s is filled, then 3d is filled. After 3d is filled, and then the 4p is filled. Clear? So that's the order in which the electrons occupy. So there is orbital overlapping. So to understand all the orbital overlapping, of course, we don't need to know all the overlappings, but just to explain how it is determined is that simply what you should do is you write the order 1s, 2s, 2p. Then you have the 3s, 3p, 3d, and then you got the 4s, 4p, 4d, and 4f14. F can go up to 14, and you have the 5s, 5p, 5d, 5f14, 6s, 6p, 6d, and it goes on like that. So what you do is you write this in the order given, and then you try to interconnect them this way. Right? And then head of one arrow, you connect it to the tail of the other arrow. Head of one arrow to the tail of the other arrow. Head to tail. Head of one arrow to the tail of the other arrow. Then you get the order in which the electrons occupy energy levels. Get the order in which the electrons occupy energy levels. Right? So the order is this. You follow these arrows. 1s, 2s, 2p, 3s, 3p. Now see, after 3p, what is filled is the 4s, not the 3d. So after 3p is filled, the 4s is filled. After 4s is filled, the 3d is filled. After 3d is filled, 4p is filled. After 4p is not 5, after 4p is not 4d. After 4p, imagine, 5s is filled. After 5s, you fill the 4d. After 4d, the 5p. After 5p, the 6s. Imagine after 6s is filled, you fill the 4f. So see, the 4f get filled after the 6s is filled. Right? So this is the order in which the electrons get filled in energy levels. Clear? So we don't need to know entire series, but if you know up to the 4p6, that's sufficient. So up to 4p6, only one orbital overlapping is there, which is between the 4s and the 3d. Clear? The question is why do orbitals overlap? That is the nature. That happens. Throughout, the orbitals won't be in the order. Sometimes certain orbitals come below the other one. Right? So therefore, please, that you should know, that the order is given here. You can predict the order from this. Right? So, why it overlaps? That is how it happens. There is no specific reason why it happens. That is the order in which the electrons occupy energy levels. Right? Okay. So let me show you a video how the shapes of these orbitals and how the electrons occupy these, especially when it comes to the order. Just to get an idea of the shape of the molecules, the shape of the orbitals. This is scandium. This is the 1s. orbital, 1s. Then you got the 2s, little bigger than the 1s. You have the 2px on the x-axis. Then you got 2py on the y-axis, 2pz on the z-axis, and 3s, you can see it's huge, bigger than 1s or 2s or even 2p. 3s is big. When you go away from the nucleus, it's bigger, the orbital. Then you got the 3px on the x-axis, 3py on the y-axis, 3pz on the z-axis, after 3p is filled is the 4s. Look, after 3p is not the 3d. After 3p is the 4s which is filled. After 4s, then you see the shape of the 3d z squared is on the z-axis. It's quite different with one dumbbell with a ring in the middle. All the other d orbitals are double dumbbells. This is dx squared y squared on the x and y axis. D3dxy between the x and the y axis, and 3xz between the x and z axis, and dyz between the y and the z axis. So this is how an atom of scandium looks like. Up to 3d is filled. 4s is filled first, and then the 3d is filled afterwards. Clear? I hope the video was clear to everyone. Right. So now, as to the Aufbau approach, I explained last week the Pauli exclusion principle. When electrons fill there as they are on opposite spin, one follows the other. I'm going to fill all the electrons now. (3p6). After 3p6, look carefully, 4s2 is filled. After 4s2, the 3d is filled. Now look. Now the thing is, whenever there is orbital overlapping taking place, the energy gap between the lower s and the higher d is very, very small. The energy gap is very small whenever there is orbital overlapping, right? So therefore, that results in repulsion between the lower and the higher energy levels. Because the energy gap is so small, that will result in the repulsion between the lower and the higher d orbitals. So as a result of this repulsion, what happens is that the 4s level cannot come down because below you have the 3d which is completely filled. So because of this repulsion, why they repel in the first place? Because the orbitals, whenever the overlapping takes place, they are almost next to each other. When the overlapping takes place, they are almost next to each other. Where then they are next to each other, then the repulsion takes place. So the s orbital cannot come down, neither it can go up, and it cannot come down. Right, so as a result, what happens is the 4s goes back to the original higher level. That is, after electrons are filled, the 4s goes back to the original level. And as the original level, what I mean is the higher level. So this is the 3d, and you have the 4s. So the 4s level goes to the higher level, 3d becomes lower. So this happens after electrons are filled, right? Now, why did I explain, if this is the case, why did I explain in the first place the orbital overlapping then? You might wonder, why did I mention that? So just let without mentioning, right? The reason I mention is to show that the 4s is filled first and then you fill the 3d. If not, what happens, you have say 5 electrons here, you start filling all the 5 electrons in the 3d and nothing will be filled in the 4s. Right? So first you fill in the 4s, then you come back and fill the 3d. And when the electrons are removed from such atom, meaning during ionization, what is ionization? That is the removal of electrons. During ionization, electrons are removed from the higher 4s2 level, not from the lower 3d level, right? Because the 4s2 is filled first and then the 3d, because 4s2 is below the 3d. But after electrons are filled, it goes back to the high level, right? Goes back to the high level. Let me write the configuration of titanium. So this is 1s2. I told to write a comma, if you remember last class, between main energy levels, 2s2, 2p6, got the 3s2, 3p6. You write the 3d, but you don't fill it. You write the 3d, but you don't fill it, right? You fill the 4s2, and then you come back and fill the 3d level. There's 22 electrons, so 2 plus 2, 4 plus 6, 10, 20, and 22. Right? So you don't fill the 3d first, rather you first fill the 4s2 and then you come back and fill the 3d. Am I clear? Right, good. I'll explain again. If you write like this, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d2, this is wrong. That means after electrons are filled. If you write like this, this is wrong. Because after electrons are filled, that means the 3d will be the higher level. Then during ionization, what is ionization? Removal of electrons. You start removing electrons from the 3d now. Whereas the outermost shell is a shell where the electrons are removed. So you cannot remove from the 3d, rather you have to remove from the 4s. Right? So the outermost is the 4s. So writing like this is wrong. Asiluna, I'll explain again. When orbitals, the orbitals are usually, there's orbital overlapping during 4s and the 3d. During 4s and 3d, there's orbital overlapping. Right? So the 4s level is below 3d during the orbital overlapping. I hope you understand this order, right? So after the 4s is 3d. So 4s is filled first in the 3d. So because whenever there's orbital overlapping taking place, right? I will draw before like what I drew before. The 4s level is below the 3d level. So you know, listen carefully. 3d is over here. So 4s is filled first. The 3d is filled next. And there's a repulsion between the lower 4s and the higher 3d. Because whenever the orbital overlapping takes place, they are almost, because next to each other, they start repelling. They start repelling. Right? Clear? So as a result of the repulsion, it cannot come down, because down the orbitals are completely filled. There are some more repulsion will be there. So as a result of this, the 4s level will go